So this talk is about how to relate the co-speech gesture to a phylogenetic history that is shared with all animal species. We will argue that the non-representational aspect of gestures, namely the beat-like quality of gesture, has been neglected in evolutionary accounts of gesture or current evolutionary accounts. And specifically, Susanne Fuchs and I are working on an account that suggests that gesture speech biomechanics may be a very basic or even a more primordial basis for the emergence of co-speech gesture as we know it today. And Susanne will also join the discussion and the questions at the end. So, what are we interested in? We are interested in how did co-speech gesture emerge, not necessarily how did language proper or narrowly defined emerge, right? So let's focus on the question, we have modern day co-speech gesture, how did it emerge in our lineage? I'll first give our immediate conclusions. So the first thing that I'll briefly characterize the phenomenon that needs to be explained, and we think that speech entangled gesture is something that needs to be explained. Then we all review theories on the evolution of gesture as we know it, and generally we conclude that they do not include beats in their phenomenon. Then we overview some interesting new research on beat-like quality of gestures, and that may have that connects beat-like gestures with maybe some very basic phenomenon that is also shared with other animal species. We connect with that research on the phylogenetic origins of these gestures to other animal research and relevant research that connects the complexity of the complexification of the respiratory system with locomotor respiratory coupling and bipedalism. Then we suggest quickly some possible revisions to the current gesture evolution views without actually saying whether any of these views are correct or not. We're just saying that you either treat it as a spandrel or a proper function, but I'll go into this later because we don't have a lot of time. So what do we need to explain if we look at current day gesturing? Let's just look at some gestures, right? And then we can comment on them.
Aber wir waren nicht darauf vorbereitet, dass einmal Druck auf unsere Außengrenzen entstehen könnte, zum Beispiel durch Luftbewegungen, und haben erst im Nachhinein Vorkehrungen treffen müssen durch gemeinsame Grenzschutzpolizei und vieles andere mehr, diese Freizügigkeit im Innern abzusichern, und daran müssen wir weiter arbeiten.
So these gestures, if you're gesture researchers, we tend to focus first on some of the beautiful aspects, namely symbolizing functions of gesture. Here she says something about pressure on the borders, I believe. And she also shows a compartment between these gestures, between inside and outside, and pressure on the borders. So this is a representational quality that you often see in co-speech gestures. But at the same time, there's also something called multimodal prosody. She's using this representational gesture, but overlaid on this is an oscillatory kind of beat-like quality that synchronizes with the prosodic inflections in her speech. And it's a research line in itself in gesture research called multimodal prosody. But this is a very basic kind of rhythmic trembling of the hands that synchronizes with speech, and it's something that can operate next to the representational quality of gesture. And let's call this the speech entangled phenomenon of gesture. Instead of saying co-speech gesture, you could say speech entangled gesture. It would be a better kind of characterization. So that's the thing that we need to explain if we are interested in an evolutionary account of gesture. How did that speech entanglement happen? So if we review the theories on the evolution of gesture, and I'm not going to review them all, we can have the gesture first, the gesture dominant, and the gesture speech together, right? The gesture first suggests that at a certain moment, gestures were more dominant and spoken language followed. Then you have those that suggest that gestures have a particular mimetic function that was dominant at developing stages of spoken language and very important for developing stages of spoken language, though vocalization was always there. And there are those that suggest that gesture and speech co-emerged as they provide a efficient combination of representational affordances that they both have but do not share, but can in unison actually be very powerful. So for example, Zoilik's view in Botolang, but also Kendon, McNeil, and Fröhlich, and Leveson, and others. However, they disagree on obvious chronology of things, right? But they all agree on one thing. The reason why gesture proliferated is that the representational affordances are unique of manual movements. They are powerful, and they're central to their functioning and their proliferation as a communicative mode as we know it today. So it's always the representational aspect that is focused on. So this is problematic, but because of course then we forget about the beat quality of gesture, right? So if you look at Tomasella's book, Corbella's account, or Levinson and Holler, the beat quality of gesture, or beat gestures, if you want to see it as a monotone concept, are not mentioned at all explicitly. If mentioned, for example, in a recent, really lovely account by Fröhlich, beat gestures are put on the phylogenetic timeline. About 500,000 years ago, they should have emerged. Much later than the referential use of gestures. So the representational quality of gestures was 2 million years ago, and only 1.5 billion years after that representational capacity, the non-representational capacity emerged. So it seems that the representational capacity is more primordial, more basic than the non-representational beat-like quality of gesture, which is interesting, right? And maybe there's good reasons for this. So let's not make it a straw man. Why is the beat-like quality of gesture rightfully, possibly marginalized? Well, as Raffagnani and Klotzep argued, and I think you'll also see this in Tomasella and Corbella's work. If you look at our closest living ancestors like bonobos and chimpanzees, we've yet to see a fully formed beat-like quality of gesture, right? So, and of course, if we look at most evolutionary accounts of gesture, they like to explain or give the explanatory weight to gesture that is quite heavy because they need to explain language proper. A beat-like gesture will not give you the capacity of language. So why look at it? So it's also something that maybe is too lightweight to serve our interests, right? And then there is maybe the definitional issue, namely similar in developmental psychology. It's held that representational gestures like pointing or didactic gestures, right, or representational gestures like iconics emerge earlier than beat gestures. However, this depends on your definition. If you say that a beat gesture is only there or only exists in a child when he or she is able to form a well-formed sentence with a nice pitch accent that has pragmatic purpose, together with a gesture, then it's a beat gesture, then it's fine. Beat gestures happen later. But you have something like focal motor babbling. It's the rhythmic movement of vocalization and hand movements at the same time. And that happens at 9 months of age, much earlier than any kind of gesture that emerges. So in that sense, you could say beat-like quality of gesture is earlier, right? So it depends on the definitional issue. The definitional issue, however, cannot explain why we would omit it out of the entire evolutionary accounts of gesture and not talk about it. It cannot be only a definitional issue, but it surely matters, right? So theories on the evolution of gesture, the conclusion is there is not a lot of focus on beats. They are not within their explanandum, it seems. So let's now briefly overview some empirical insights on why we should look at the beat-like quality of gesture, especially for evolutionary accounts, because they might have a very basic origin. So it is tempting to think that when we move our arms, we are only using our focal muscles, like the biceps, the triceps, maybe some muscles around the shoulder girdle. However, we should appreciate that humans are in a precarious position to gesture, right? And Walkman and Shipman characterize it from an engineering perspective. Bipedalism is a ridiculous answer to the need for locomotion, posing a problem akin to balancing an apple on top of a moving pencil. Now we can add to this two upper limbs in a gesturing mode, right? Two chaotic pendula that we add to this very precarious postural equilibrium, right? Or disequilibrium at times. And now it's not difficult to see that any gesture actually requires a whole coordination of the body. There is no manual gesture proper. There is a gesture that is always a coordination of the whole body. To be very precise about that, we can look at the anatomy and maybe see why this is so. For example, you can see that the humerus is inserted in the shoulder girdle. It has the clavicle here, and it has the scapula here. The clavicle is the only supporting bone that carries every vertical or other directional weight bearings, right? And it's a very precarious position. It's actually horizontal. So any vertical kind of pressure you get on that, it's not very well posed to deal with vertical compression because it will break easily. Indeed, people are saying that if you just look at the clavicle and you would not consider all the other things, then just moving our arms would break the clavicle, let alone if you have to hold your groceries, right? Because it's in a very precarious horizontal, non-weight bearing position. And even humans often break their clavicle. It's one of the most broken bones, or most often broken bones. But so how is this? How is it that our upper limb system is suspended on this very precarious threat? Well, it's because there is a tensegrity phenomenon going on. Namely, this whole system, it's like a wheel with spokes and with the compressive elements, the bones, but also tensioning elements, tent-like kind of connective tissue and muscles that keep everything tensioned and stabilized. So you have, for example, the serratus anterior posterior. It wraps into the scapula on the back, and it wraps around your chest and connects with the thoracic region. It inserts on your rib cage. And there are many muscles like that on the back, but also in the shoulder girdle, like the pectoralis minor. And what this means that the reason why this is a stable system is because it is tensioned. It has a pre-stress that allows that if you have a force, that it distributes to a wider system. So what this means that any force that you're producing on your upper limb system will distribute over this whole system, over these tensioned elements. And these forces will distribute over the entire thoracic region. And this may affect respiration, right? Finally, I won't go into this too much, but if you think about the pencil, if I move my arms, I also need to activate anticipatory postural adjustments, such as muscles in the back, but also, for example, primary respiratory muscles like the diaphragm contract to stabilize your whole posture so as to not fall over when you're moving your limbs in a direction, in a forced direction that leads your center of mass to shift if you would not change your posture, right? And biomechanicists have indeed shown that even if you move your upper limbs, that, for example, the anticipatory postural adjustment or these muscle activations involve respiratory muscles and also affect intra-abdominal pressure and therefore also affect respiratory dynamics. So the next step is, okay, if the upper limb system is very much connected to the respiratory system, it's not a difficult step to make that it also affects our vocalizations. And it is indeed something we have found in a number of studies. I won't go into it too much, but what you generally see, if people move their hands in a sudden stop, for example, a beat-like quality of gesture, you'll often see if people are vocalizing at the same time, these increases in the fundamental frequency or increases in the amplitude of the sound. They cannot do anything about it. If you're instructing them not to do it, they will do it anyway. And it's at the moments when you have a deceleration, a forced transmission, or a mechanical loading of the upper limb on your body, that you see these inflections in the vocalizations. And these inflections are functioning in spoken language often as acoustic markers of prosodic stress, right? So that's why gesture and speech might be coupled in this way, or at least this might be the reason why they are generally coupled this way and may amplify it cognitively, right? If people are standing, these effects are more extreme than when people are sitting. If you measure their thoracic movements via respiration belt, you see that when there is a more higher deceleration of the hand or even the wrist, you'll see that there are chest movements that also directly translate into the vocal inflection or the degree or the amplitude of that inflection. And we have even found that people can listen to somebody else moving and vocalizing at the same time and then synchronizing with their own movements, which means that people are actually quite sensitive to this information in the sound. They not only detect the rhythm by moving at the same rhythm, but they also know when the hand is in the beat-like phase or more in the upward phase. And they can do it even with wrist motions. So there is an empirical basis for the idea that there is a biomechanical link between vocalization and manual gesture, right? And this is nice because it might connect up with a whole host of research, and we can maybe push this beat-like quality of gesture way back in the phylogenetic tree, right? Something that is necessary if we want to say that it's perhaps basic or primordial, if you like that term. So if we connect that, we just have to read about a large number of studies on quadrupeds or four-legged mammal family members in our phylogenetic tree, namely horses, geese, and cats. They all, when they are locomoting, they are obligated biomechanically to synchronize their respiratory cycles with their strides. If they're running, their respiratory cycles have to go faster. When they're walking, they still they will be slower, and there is a one-to-one synchronization because this is optimal or it's biomechanically efficient because you have these upper weight or these weight bearings on the thoracic region through the upper limb system every time you hit the ground, right? This will affect your respiratory cycle necessarily through mechanical loading. It is suggesting that it's not ideal to one-to-one couple, right? It's a quite heavy constraint that you may at times want to avoid. So it has been said that some creatures or some organisms have actually adapted their locomotion induced coordinative challenges for the respiratory system. For example, you have gular pumping and monitor lizards, which run like this. If you look at the top, they walk like this, and this actually compresses each time their lung. This is not ideal. And what they've adapted it with, that they have an air sac that actually pumps extra air and gives a certain pressuring stabilization of their respiratory system, and it's set and it allows them to be less coupled to their locomotion, their respiratory cycles, right? Crocodiles have a specific pump-like diaphragm that actually allows to completely decouple respiratory and locomotion cycles. So they have a morphological change there. And we can even wonder, but this is speculative and it's not my domain of expertise, but the air sacs in non-human primates that we have lost throughout our history, right? But all non-human primates, and most of all, have all these different kind of air sacs, and it might be due to some kind of stabilization process during brachiation and avoiding maybe one-to-one coupling with the respiratory thoracic region when hanging on a tree or when swinging from a tree, which is even worse, right? Biomechanically, the forces are even much higher. And Hayama has said something like this, but his article is in Japanese, so anybody has a translation, I would love to see it. But he said something like this, that the air sacs might have a function of stabilizing the respiratory system. So Carrier has suggested that bipedalism is one way to avoid the one-to-one coupling because you're not loading anything, your locomotion anymore on your upper limb system, on your thoracic region. And indeed, if you look at birds that locomote bipedally, right, you see that they still couple a little bit, the same, by the way, as humans, but they couple in a much more flexible way, like in polyrhythms, like 3 strides with 1 respiratory cycle, and they are much more flexible like this. And so it seems, and Carrier and all suggest, that bipedalism is actually an adaptation to give flexibility to the respiratory system, to not couple one-to-one anymore with locomotion and respiration. And they suggest that might be actually quite helpful if you want to have a complex respiratory system that can support speech, right? So I have to go fast, but from respiratory to vocalization, it's not a big step to go to respiratory vocal coupling. So in bats, you see that there is locomotion respiratory vocal coupling, such that their echolocation bursts are synchronized with their wing beats because their wing beats are affecting the same system. Even the pectoralis that we share, the muscle system that we share, is actually synchronizing with the vocal coupling, and brown-headed cowbirds also do this. Now, I have to go fast because I don't have a lot of time anymore. Let's accept that the respiratory system has adapted to speech. These respiratory adaptations are, for example, shown in the well-known finding that the canal size of our nerves have grown, and they cannot be attributed to bipedalism, but it has been suggested that they can only be attributed to a more complex vocal system because that thoracic canal houses the respiratory nerve control, but it also houses, coincidentally, the upper limb system. So it could be that it's not only the complexification of the respiratory system, but also our manual system that is correlated with the canal size increase that is shown here. So that area has grown for Neanderthal in humans. So I want to go further than this because I don't have a lot of time anymore, just 1 minute. So if it's the case, what kind of revisions do we want to say? Bipedalism freed humans from locomotor rhythms, right? The obligatory one-to-one rhythms. But upper limb movements, the respiratory system was not freed from the upper limb movements. They were always there, now in gesturing mode or now in different kind of rhythms that were sustained in these movements. So the manual, we could even say that the manual's intentional patterning that is generally attributed to the manual system, much more intentionally controlled in our vocal system, or at least in our ancestors, right? That they might have co-opted, they might have helped the vocal system in this way. So, for example, we know that bats in their can vocalize when they're just sitting and not flying, isosceles, in an isosceles way, in a social context. And it has been suggested that their isochrony, or their ability to sustain a isosceles signal, was actually attributed because of their wing beat, locomotion, respiratory vocal coupling. So you have one domain or one ability that is actually might be dependent or might be co-opted from biomechanical stabilities. And that's one suggestion. The same thing could happen with gesture, right? I have to end. We could have two options. Either we're going to go for the gesture first, and we're going to say gesture emerged first, but at some point we needed to vocalize, and we indeed vocalized. And then you can say, well, we had this manual system with intentional control. Because of biomechanical interaction, they actually help the vocal system to behave and gain new stabilities at some point, right? You might have gesture first, that's fine. Or you can have gesture speech first, as gesture speech together theories, where you say, or it is a spandrel, or it actually has a function. So we know that there are indexical cues, such as some animals can detect the body size or only bodily capacities from acoustics alone. And we have, for example, found that people can listen to somebody's sound and can synchronize the movements as well. So it might be some kind of indexical cue or some kind of emotional kind of way of expressing yourselves through bodily or acoustics that are informative about the body. So we can communicate in the dark, and we don't hear an abstract sound, but we hear an embodied sound. We hear a body at a distance. So I have to stop here. I'm sorry, I'm going 2 minutes over. We're happy to take questions.